Hi, I'm Jackie Bono. I'm a teacher from Massachusetts Academy of Math and Science. I usually teach physics and chemistry, and I usually teach an elective in forensic science. And today we're going to be doing Lab 7 out of the Vernier Forensic Science book. It's a lab that does drug testing, and it's doing a little bit of qualitative analysis. And all of the labs in that particular book are going to give us a scenario, and that scenario gives us a setting for the lab. In this particular lab, we have Yuri Orlo, who's been pulled over and considered to be drunk or intoxicated in some fashion. And in doing some testing, they also noticed some white powder on the front seat. So the question that's posed to the students is, what is this white powder, and should the police, in fact, press additional charges, possibly of drugs? And so we've taken some samples of some white powders, and we're going to try and identify what our mystery unknown is and find out if Mr. Orlo is, in fact, a drug user. And if you take a look at the teacher's notes in the books, they give you some suggestions for those powders, and I've taken some of those powders and put them out here. As a classroom teacher in a high school, using real drugs obviously isn't going to be a very good solution for us, so we've actually used some very common things like flour and baking soda and baking powder, salt, sugar, and any other white powder that kind of looks the same for students. And what we've done is we've taken and we've weighed out samples, and we've put them into 5 beakers, 1 through 5, and then we've taken some of our mystery unknown and we've put it in beaker number X, or letter X. And if you follow the instructions, the first thing that you're going to have to do is you're going to have to have the students weigh out the white powder, and then have them take 50 milliliters of water and pour it into each of the beakers. And so we're going to just do some of that now. The problem with this particular next step is going to be that we then have to let them sit for 15 minutes and stir it every 3 minutes. Now that poses a little bit of a problem in my classroom, because sometimes my students are on task, and sometimes my students, given 15 minutes to do nothing but swirl a beaker, could be a little bit off task. So what I suggest you do is that while you have your students do this next part, that you also then go on and do some of the other analysis, which you can do, and we'll speak to that in a minute. So I'm just going to continue pouring my water into those beakers, and then I'm also obviously going to pour the water into my unknown. We're using distilled water. I've done this lab without distilled water. It depends upon how much distilled water you have, and if you're in a high school, you oftentimes have access to a lot of distilled water. If I'm doing this in a middle school, distilled water could be a little bit of a problem, and it works just fine with tap water as well. So I've got 50 milliliters of water in each of my beakers, and all my kids are going to do is every 3 minutes, for 15 minutes, they're going to swirl these beakers. And again, I now have this downtime, but I do want them to be observing what happens in those containers. So while my kids are doing that, I suggest that we get out our magnifying glasses, and our magnifying glasses can be something like this that I buy in the dollar store, or they can be your magnifying glasses that you have for your biology sections or things like that. And I ask the kids to look at all of the samples and decide what crystals look like. And what we've done right here is we've taken some of the crystals and put them on a dark background so that we could see them. And with a magnifying glass, we can see that these particular crystals are very cubic in nature. And so the kids would record that in their data, or you could even ask them to draw it. They're very distinctive in shape as compared to this particular one, which when I put that out and try and spread it out on a dark background so that I can look at it, it's very definitely much more powdery, and I can't get any distinct crystals. They almost look like they're elongated rods. And so the difference between these two substances is obviously very clear, and as we go through each of the other substances, we will see exactly the same thing, that there is a little bit uniqueness about each of the substances, hopefully, but not so significant that I could just look at the unknown and tell which one it is. I recently did this lab with a group of teachers in Texas, and my unknown was one of the 5. It was actually a combination of one of the 5s. But for the sample that they put in as a sample 1, 2, 3, 4, 5, I had ground it down And for the unknown, I had left it as a clump. And so many of them, just by doing cursory observation, couldn't tell what the unknown was, unlike the difference between sugar and baking powder or sugar and flour. So as these things are swirling, and as you are waiting to see the relative solubility of these, that's one of the things that you can be doing. The other thing that you could be doing is one of the other tests that we do in this particular lab is we see how they react to vinegar. And all you're looking to do is to see if, in fact, we get bubbles or don't get bubbles, and how violently it bubbles. And so as we are swirling, and in my classroom, what I actually have a stopwatch is so somebody's sitting there with a stopwatch, and they say, okay, swirl, and they swirl. And then when it hits to the next 3 minutes, you'll hear them say, okay, swirl, and they stop what they're doing, and they swirl. And so all we're going to do now is take each of the samples, put them in a cup, and you want it in a cup because the vinegar will bubble violently in some of these cases, and you don't want vinegar all over your table. So I tend to use big cups a lot. And just pour a little bit of vinegar in. If you want, you could use a pipette and see what happens. And again, the students have log sheets, and they're recording those notes in those log sheets. And they're telling me how much it reacts or doesn't react. The other nice thing about this lab is that it uses very common household things. And I'm getting lots of bubbles with this particular one, which happens to be number 4. Where with the other one, I didn't get quite so many bubbles, but I got bubbles. And again, I'm going to do it with each of my samples, and I'm going to do it with my unknown and see what happens. And in this case, nothing at all happened. And so I'm recording all of that data right down on my log table. And again, I just keep swirling. And once that 15 minutes has passed, I'm going to start taking notes on what these solutions look like. So this one here is still fairly cloudy. This one here is very clear. It looks like it totally dissolved. This one here is fairly clear, but I have some solid on the bottom. Again, this one is cloudy. This one here is clear, and I have a little bit of solid on the bottom, but not as much as the other. And this one here is clear, and I have a little bit of solid on the bottom. If all of these samples started out with the same mass, then how much was left on the bottom would be significant. So you want to make sure that the students have actually weighed that out, or if you are in a situation where you have a short period of time, that you've weighed out those samples for the students yourself. Once this part of the lab is over and you have your 5 samples and you know their solubility in water, then you're going to go on to your actual testing with the science probes. And the 2 probes that this particular lab uses is the pH probe and the conductivity probe. The pH probe obviously tells us how strong an acid or a base our solution is. And the conductivity probe will tell us how many ions we have, a relative measure of ions. And what we're going to be doing in this particular case is we're going to be comparing the readings of our known standards to our unknown. The probe that we're going to be using again the first time is the pH probe. We're going to plug it into an interface. In this case, I have the LabQuest, and the LabQuest is going into a laptop or a desk computer. And when I do that, I just plug this right into 1 here. I've opened Logger Pro, and you can see that when I opened Logger Pro, it automatically knows that I have a pH sensor. So I have a graph here, and in the lower left, I have this little meter. It's a useful screen, but for this particular lab, we've designed a better screen. So in order to get there, I'm going to go to File, Open, and I'm going to find the Forensic Science book right here and double-click on it. And I'm going to choose Lab 7, which is the lab that I'm doing. Double-click on that. And it will open a file that's going to give us a very large meter here in the center, a graph on the bottom right, and a data table that will record my samples on the bottom left. So when you're using a pH probe, what you need to do is you need to unscrew the pH probe here from the bottle. As a teacher, I've learned not to take the cap off. The reason I don't take the cap off, I simply push it up, is that I found that when I took the cap off, I lost the rings, because the students weren't careful with them, pH probe is already calibrated. I don't have to worry about that. So I'm going to take the pH probe. I'm going to take some distilled water. I'm going to rinse it off. And it's important that the kids rinse it off each time. I'm then going to take my solution number 1. I'm going to come over. I'm going to measure the pH of solution number 1. And as I do that, I'm going to hit Start, which will allow it to start to collect data. And you'll notice that when I did that, the Keep button became very dark as well. When this number stabilizes, and it looks like it's changing a lot, but remember it's changing in the 100th place, so it's changing, but not as much as it appears to be changing to us. I'm going to hit Keep. It's going to average the numbers together over several seconds. See that blue line coming across as it's averaging? And that point now will be plotted on the graph and entered in the data table on the bottom left with the sample number and the reading. And it says 5.97. Take and rinse that off. And I'm going to repeat the same thing for sample 2. Giving it a minute to stabilize. I hit Keep. It averages for me and puts it in the data table. I'm using my pH probe in this particular lab as a meter. The pH probe actually has lots of different settings, but in this lab we're using it as a meter. I'm going to repeat it for all of my samples, so here I go. I'm going to do it again. And this one here is basic. It's 8.05. One of the things I found in my classroom is I sometimes, instead of doing it like this and having everybody have all of the probes, I will set up stations, and the students will have stations where they're looking at solubility, stations where they're looking at the crystals, a different station where they're measuring pH. And that allows me to have less probes out if I don't have quite as many probes as I do groups. It also tends to give everybody a job to do so that I can make sure that all of the students are involved. This particular lab, although it's a forensics lab, I also would use it with my introductory chemistry class because it's very much qualitative analysis and all of the properties of qualitative analysis. I mentioned when I started that I teach a forensics elective. Well, not all the kids take my forensics elective, and so consequently what I need to do is I need to have other places to use these labs. And that's kind of the nice thing about forensic science, is that it is in fact an integrated science, and I can use the labs in this book in many other classes. And again, all I'm doing is events with entry. When it stabilizes, I keep, and it records for me. And after they've done all 5, they're then going to do the unknown. Now, I'm dealing 5. You could obviously have 10 or 15 of these if you wanted to do many more, and that's really up to you. And so here we go. This is my unknown now that I'm doing. Sample 1 through 5 are our known samples. Sample 6 is our unknown here. It's also recorded on the lower left-hand corner on the data table with the sample numbers 1 through 5 and 6, 6 being the unknown. Some students look at this and say, oh, at number 6, our unknown has to be 3 because they both are higher than any of the others. I caution you to warn students that one test alone does not determine an unknown, and the unknown obviously can be more than one thing. That's all set with the pH probe now. I'm going to rinse my pH probe off very well. And I'm going to do the next probe, and the next probe is the conductivity probe. When I put my pH probe back after rinsing off, I'm going to do just what you didn't want to do. I'm going to put the cap back on, move it down, put it back into the pH bottle. This pH is stored in a storage solution that comes with the sensor. If the students spilled it, you can make new pH storing solution, and the directions are on the Vernier website, or they're also come with the probe. I'm now going to change probes. I'm simply going to unconnect or disconnect my pH probe from channel 1. I'm going to move it over here out of the way. I'm going to get my conductivity probe, which looks just like this, and I'm going to plug that one into channel 1. We're now going to measure conductivity, so we need to open a file again to find that. So we're going to go back to Open, File, Open. We're under Forensics with Vernier, and you want to go to 7B for drug testing. And now instead of measuring pH, it's going to measure conductivity. It asks you if you want to standardize it or use the probe as is, and we're going to use the sensor setting. And it's measuring at this point. And again, what we have is a large meter, we have a graph in the lower right, and we have a data table in the lower left. And if you take a look at the reading that I'm getting here, I'm going to just put it in some distilled water, and I'm going to put it into sample 1. Once I put it into sample 1, I'm going to hit the collect button on the top here. When I do that, you'll notice my keep button becomes dark, and I'm taking a reading of conductivity here. When it appears to be stable, if I press keep, I'm going to get that same screen I got before, and it's going to average the readings over several seconds and take that point, mark it on the graph, and put it in the data table. I'm then going to take and rinse my probe in distilled water and continue this process through the other samples, including my unknown. I'm going to wash my conductivity probe. And this is another lab with events with entry, so I wash the conductivity probe. I say collect. I come over and I measure number 1. And again, it should somehow relate to how much stuff dissolved, although it's not a direct relationship to that. It is related to that. When this thing looks like it's stable, I need to move my mouse, hit keep. It's going to take and average the readings. As it averages the reading, I then go on to the next one. It again records it in the data table. I rinse off the probe. I put it into number 2. And I repeat this procedure for all of them. Depending upon the group of kids, I sometimes number them 1, 2, 3, 4, but I sometimes give them drug names. And then if it turns out to be one of the drugs that are drugs, like cocaine, as opposed to aspirin, then that means the person should be proven guilty and in fact have additional drug charges waged against him. If it turns out to be aspirin, or if it turns out to be something that's not a drug, then obviously the man is innocent. As a classroom teacher, you need to make sure that the guy's not always guilty, because if you don't do that, the students quickly learn that he's going to be guilty no matter what, so why bother going through the lab? And that's not a good idea. So you want to make sure that you do change those things. I'm doing this one. Oh, this is really high. Number 3. And when that's done, I will say keep. It will average. When doing the book, or when using this book a lot, I didn't really know what age level it was appropriate for. And I have to say that for many of the labs, it's appropriate for both high school and middle school. And middle school students will not have a problem doing any of these activities. So you can tie it in where it best ties in for you as a classroom teacher. And those decisions are decisions that you as a classroom teacher really need to make. Just let that finish. The lab can easily be completed in a normal classroom period of about 45 minutes. If you find that it's not working really well in a classroom period of about 45 minutes, there are some things that you can do that will speed it up. One of which, of course, is to weigh out all the solids for your students. If you only have 1 or 2 balances in the room, sometimes that's really helpful to do. Another one is you can cut that 15 minutes down a little bit, but don't cut it down too much, because you do want to give it time for the solids to react. And You'll notice now we've done all 5 of our samples on our unknown, and once again, the sample numbers are 1 through 6 over here on the lower left in our data table, the first 5 being known powders, number 6 being our unknown, and students can see the readings in the data table and can see it also plotted on this graph that's adjacent. Many of these samples have a high conductivity, so this test tends to be a little less conclusive than our pH. And again, caution students to be aware that their sample may be more than one substance, and therefore one test alone will not determine the answer. Once they have all those results, they have them on their log sheet, and they can in fact tell you the results of their investigation. Hopefully they can identify their unknown. If I do this with a group of mixed ability kids, I give kids different unknowns. The higher level student, I may give an unknown that's mixed, that's not real obvious. Whereas the student who is struggling a little bit more, I may give him something that when you look at it and you look at the numbers, it really fits very classically into one of those solutions. So you, again, as the classroom teacher, need to decide how you're going to differentiate this instruction. This lab can be downloaded by you from the Vernier website under Forensics. Student pages can be printed and given to your students to use as is. There's a log page or an evidence report for your students to use. Teacher pages are also found there that will give you additional hints as to some of the activities that you can do to supplement what we just did here or other resources. Answers to the lab are not found on that web page because you are, of course, going to do your own thing with your students.